So, getting on to some of the stories that I found interesting this month, uh, I've got a couple stories on supernova explosions. This here shows a panel of a mechanism that are a couple mechanisms that of which a type 1a supernova can be produced. In either case, the culprit starting star is either one white dwarf or two white dwarfs, in this case, two that merge to form a supernova, or in this case, one that is in a binary star system where the other one is starting to evolve and it starts to accrete material from that other star there. And then eventually, white dwarfs are composed of carbon and oxygen from a dead star. Our sun will become a white dwarf. But when it gets up to a sufficient mass, it can no longer hold itself up. And that mass is 1.4 times the mass of the sun. And so if it accretes enough matter to get over that region, it blows up in a supernova. And these supernovas still have quite a bit of energy in them, in the sense that carbon and oxygen can burn on to other heavier elements. And in general, these type of supernova burn on to iron and nickel. And so in this mechanism here, where you have the binary system, it accretes on here. This one, you have two white dwarfs that then spiral in to form also over that 1.4 times the mass of the sun region where it blows up in a supernova. We do not know which of these mechanisms is involved. We're fairly positive that a white dwarf is involved, but what is creating these? So that was actually the story for this week. And before I get to the punchline, one of the things that is done in trying to model these supernova is to model the ignition of one of these white dwarfs, and they do those with computer simulations. And so here is computer simulation panels here, going from where it starts in the center and then blowing out in this particular direction. It's always an asymmetrical thing. So one of the movies I was going to show you was going to be this next one, which I will see if it actually plays. It's as though these movies haven't been loaded, so it's not going to show you the simulation. It wasn't a very high resolution simulation, though the individual panels that they take from those are just spectacular there. So here is, they're done in very high resolution. There's beautiful art in terms of what's going on there. So the explosion starts off here, ends up over here, and if I could have shown you the video, it engulfs the entire star, and then eventually the whole star is actually disrupted and sent back out in space. So these supernovae are very, very important in many respects. One is that they put heavier elements back into the interstellar medium. We started off with a universe that was just pretty much hydrogen and helium. How do we get all the carbon and oxygen and stuff back into other stars and planet systems like our own? We had to do it through supernova. So it's key that we understand what this process is all about. These supernovae are also we're using as standard candles, which means that when they blow up with a brightness of known value, and therefore we can identify how far away the object is that they blow up in. So we use those to figure out distances to galaxies and map the acceleration of our universe. So we really do want to understand this mechanism. So in the story for this month, what further simulations of these white dwarfs that were blowing up, a guy named Dan Kaysen at Berkeley was wondering, what happens to the star? Say it's in a binary star. What happens to the star when a supernova blows up? Does it actually survive that explosion? We've asked that question before, but no one really had modeled that. So he has been doing some modeling, and he came up with a very interesting potential observation for these objects. And this is not on the same scale that I showed before, but basically this envelope that you see here in this model is the exploding star that started over here, and this here is the embedded star that is around that white dwarf that blew up. And the significant finding that he had in his simulations is that when this happens, that this after the supernova, an ultraviolet flash is actually emitted from the supernova there. So if this is the mechanism where you have a white dwarf accreting from another star, then you should see an ultraviolet like flash. Well, it turns out that in the research that they've done, they have found ones that have flashes and some that do not. So right now, they believe that both mechanisms are, and in fact about half and half on the observations they've been able to take, that they think that both those mechanisms are actually in play. There's still a lot of unknown questions, and this is, this is just helping us figure out, what's going on with those systems. But these actually go off. About 1% of the white dwarfs that are created end up in these supernova explosions. We still don't quite understand, why so many of these systems, whether they be an emerging system or accreting from another star, why so many of them are actually going off in supernova. So my next story is actually kind of related to that same kind of topic, and that is supernovas that are not 1As, but they're called 1Bs. They are supernovas that are identified as having being calcium rich there. And here are two supernova that had went off in this galaxy and in this galaxy, and they were way out here on the outskirts of these galaxies. Now, you notice anything peculiar about those galaxies? They've got some junk in here. Basically, these are merging systems, and one of the telltale signs of those are these shredded remnants of a galaxy merger. So there were 13 of these supernova that they were looking at that were calcium rich, and that one of the things that they noticed was that they were all coming from galaxies that were part of merging systems. The next thing that they measured when they looked at these supernova to see, maybe they were created out here, they found that they had very, very high radial velocities. In other words, velocities that are coming toward them. And the indication, or away from them, the indication is that these velocities are similar to stars that we have found that have been ejected from, say, the Milky Way or other galaxies. When the ones that we've studied here are Milky Way ones. So it appears that these systems were down in the core of this merging system. So, and these are fairly unusual. So what is the full mechanism that actually is creating these type of supernovas? The calcium rich also indicates that the white dwarf actually does not blow up and use all its energy. It ends at it's like thwarted in its explosion, where it ends at calcium rather than burning up to iron and nickel. So anyway, the researcher that who came up with this theory, this is the scenario that he has for these very unusual supernova that seem to be going off in the wrong place in the wrong time. Is that you've got a merging system of galaxies. In the cores of each of those merging galaxies is a black hole. Those black holes are eventually coalesce, but they all, when the galaxies merge, they bring an entourage of stars with them. Some of those stars are binary systems. Some of them are binary systems with white dwarfs, like this one shown here. And what ultimately happens to that white dwarf system is, one, the system's orbit gets tighter and tighter by that interaction, and it gets ejected from the galaxy. So this mechanism can solve two things. One, they need them to spiral in closer and closer so that they can go supernova in an appropriate amount of time. They've been ejected from the galaxy. We see them out here at the edge of the galaxy. They're only going to be out there where we can observe them for 50 million years or something like that. So they have to have been put in these tighter orbits, and then they go supernova. So it's a very interesting mechanism. We'll see how it actually plays out. But some star systems are in very strange systems. We will be emerging someday with the Andromeda galaxy, and we each have black holes in the center of our galaxies. We might be in a similar thing where we get ejected. We don't have a binary system, so we don't have to worry about supernova or anything like that. But we may be in one of these type of star systems one day in a few billion years. Don't worry about it. Okay, my last story.